Light fixtures installed on a 9-foot ceiling in patient exam rooms are not mandated to have redundant grounding according to prevailing electrical codes. The requirement for redundant grounding, which involves having two separate grounding paths, typically applies to specific electrical equipment and receptacles within the patient care vicinity. This is primarily intended to minimize the risk of electrical shock to patients and medical personnel. In patient care areas, the concept of equipotential grounding is crucial. Equipotential grounding ensures that all exposed conductive surfaces are at the same electrical potential, thereby reducing the possibility of voltage differences that could lead to hazardous current flow through a person. Receptacles and other electrical devices within the patient care vicinity are subject to stringent grounding requirements to achieve this equipotential state. The National Electrical Code, or NEC, provides detailed guidelines for grounding and bonding in healthcare facilities. Specifically, it addresses the requirements for patient care areas, including exam rooms, operating rooms, and critical care areas. These requirements are designed to create a safe electrical environment for patients and healthcare providers. Section 517 of the NEC covers healthcare facilities. This section outlines the specific grounding and wiring requirements for patient care areas to minimize electrical hazard. The NEC defines patient care areas based on the level of risk associated with patient contact. General care areas, such as exam rooms, have different requirements than critical care areas, such as operating rooms or intensive care units. Redundant grounding is typically required for receptacles and exposed conductive surfaces within the patient care vicinity, which is generally defined as the space within 6 feet horizontally and 7.5 feet vertically of the patient bed or treatment table. This requirement aims to provide multiple paths for fault current to return to the source, ensuring that a ground fault quickly trips the circuit breaker and energizes the circuit. Light fixtures mounted on a 9-foot ceiling are generally considered to be outside the patient care vicinity. Because of this, the stringent redundant grounding requirements that apply to receptacles and equipment within the patient care vicinity do not typically extend to these fixtures. The primary grounding conductor that is provided with the branch circuit wiring is usually sufficient for grounding the light fixture. It is important to note that while redundant grounding may not be required for light fixtures on a 9-foot ceiling, the fixtures must still be properly grounded in accordance with the NEC and other applicable codes. This includes ensuring that the fixture is connected to the building's grounding system through a properly sized grounding conductor. The grounding conductor must be connected to a grounding electrode system that meets the requirements of the NEC. The size of the grounding conductor is determined by the size of the circuit conductors supplying a light fixture. Table 250.122 in the NEC provides guidance on the minimum size of equipment grounding conductors for various circuit sizes. In addition to the primary grounding conductor, it is also important to ensure that the metal enclosure of the light fixture is properly bonded to a building's grounding system. This bonding helps to minimize voltage differences between the fixture and other conductive surfaces in the room. Bonding can be achieved by using bonding jumpers to connect the fixture enclosure to the building's metal frame or to other grounded metal surfaces. The NEC provides detailed requirements for bonding in Section 250. These requirements specify the methods and materials that must be used to ensure effective bonding. Regular inspections and testing of the grounding system are essential to ensure that it is functioning properly. Grounding systems can deteriorate over time due to corrosion, loose connections, or physical damage. Regular inspections can help to identify and correct any problems before they become a safety hazard. Ground impedance testing is a common method used to verify the integrity of the grounding system. This test measures the resistance of the grounding path to ensure that it is low enough to effectively carry fault current. If the ground impedance is too high, it indicates a problem with the grounding system that needs to be addressed. In summary, while redundant grounding is typically not required for light fixtures mounted on a 9-foot ceiling in patient exam rooms, it is essential to ensure that these fixtures are properly grounded in accordance with the NEC and other applicable codes. This includes providing a properly sized grounding conductor, bonding the fixture enclosure to the building's grounding system, and conducting regular inspections and testing to verify the integrity of the grounding system. Always consult with a qualified electrical contractor or engineer to ensure that your electrical system meets all applicable codes and standards. Proper grounding is essential for protecting patients, healthcare providers, and the facility itself from electrical hazards. Remember to adhere to all local and national electrical codes and regulations. These codes are designed to ensure the safety of electrical installations and protect individuals from electrical hazards. Electrical work should always be performed by qualified and licensed electricians who are familiar with the relevant codes and standards. When working with electrical systems, always de-energize the circuit before performing any work. Use appropriate personal protective equipment, such as insulated clothes and safety glasses, to protect yourself from electrical shock and other hazards. If you are unsure about any aspect of electrical work, consult with a qualified professional. Improper electrical work can be dangerous and can lead to serious injuries or property damage. Furthermore, the specific requirements for grounding in healthcare facilities can vary depending on the type of facility, the type of patient care being provided, and the applicable codes and standards. It is important to carefully review the relevant codes and standards to ensure that your electrical system meets all requirements. Consider consulting with a healthcare electrical safety specialist to ensure compliance with all applicable regulations. These specialists have expertise in the unique electrical safety requirements of healthcare facilities and can provide guidance on proper grounding and bonding practices. In addition to the NEC, other organizations such as the National Fire Protection Association, or NFPA, and the Institute of Electrical and Electronics Engineers, or IEE, also publish standards and guidelines related to electrical safety in healthcare facilities. These standards and guidelines can provide additional information and recommendations for ensuring a safe electrical environment. Ultimately, the goal of grounding and bonding in healthcare facilities is to minimize the risk of electrical shock to patients and healthcare providers. By following the applicable codes and standards and implementing proper grounding and bonding practices, you can create a safe and reliable electrical system that protects everyone in the facility. Regular maintenance and testing of the grounding system are crucial for ensuring its continued effectiveness. Grounding systems can degrade over time due to corrosion, loose connections, or physical damage. Regular inspections and testing can help to identify and correct any problems before they become a safety hazard. Visual inspections should be performed regularly to check for signs of corrosion, damage, or loose connections. Ground impedance testing should be performed periodically to verify the integrity of the grounding path. The frequency of testing should be based on the recommendations of the equipment manufacturer and the applicable codes and standards. Any deficiencies identified during inspections or testing should be corrected promptly to ensure the continued safety and reliability of the electrical system. It is also important to train healthcare personnel on the proper use of electrical equipment and the importance of reporting any electrical hazards. Healthcare personnel should be trained to recognize the signs of electrical shock, such as tingling sensations, muscle spasms, or loss of consciousness. They should also be trained to report any electrical hazards, such as frayed cords, damaged outlets, or sparking equipment. By providing comprehensive training and education, you can help to create a culture of safety that minimizes the risk of electrical accidents in the healthcare facility. In addition to grounding and bonding, other electrical safety measures can also help to protect patients and healthcare providers from electrical hazards. These measures include the use of ground fault circuit interrupters, or GFCIs, and isolated power systems. GFCIs are designed to detect ground faults and quickly interrupt the circuit, preventing electrical shock. They are commonly used in wet locations, such as bathrooms and kitchens, and are also required in some patient care areas. Isolated power systems are designed to isolate the electrical system from ground, reducing the risk of electrical shock. They are commonly used in critical care areas, such as operating rooms and intensive care units, where the risk of electrical shock is highest.